This demonstration is to show how to use my tool, which is fractal generation and mesh integration within Houdini. This is done in Houdini 17 and may suffer some issues with other previous versions of the software because of the Boolean operations and other features that the latest version has to offer. So be careful when using previous versions. That being said, this tool can be used with any mesh within Houdini or OBJ, Alembic, FBX, or any other file that is made in other softwares, so long as it is a single watertight mesh. If it isn't a single watertight mesh, then there is the ability to convert it to a volume database and then convert it back to polygons. However, this may lose its detail and can increase computation times quite a large amount, as you can see. That being said, let's start with a simple demonstration with a sphere. It must be said that all these must be polygons in order for the tool to work. And in this case, we'll increase the frequency just to make it more detailed. It doesn't matter the detail, however, it's actually better for it to work with higher detail, so long as it's, computational allows you. Next, let's go into the fractal generation, where we will create our mandel bulb. We can control its overall shape using the N or order, as well as changing elements like the theta, the phi, its new coordinate positions, and things like the phase, which is its animation. This will overall change shape and movement of a fractal. It's all created within a volume and then set as bounding boxes and converted back to volume databases. If we go into the main tool, we can see we have our target mesh, which is the sphere, which is then subdivided and divided into triangles so that we can create a much more detailed mesh. The tool works better on higher details. We'll then take our fractal, which in this case I'm using as a cache for n to the 8 order mandel bulb, just to save time here. I recommend caching it as well. We next match the size of the target mesh, which in this case is a sphere, so we get a rough size of what it should look like, and we scatter points onto the sphere. This is used as an initial guide to create and move our fractals onto it, as well as controlling how many we want. From there, we put it onto a point deform just to ensure that it stays on the mesh if it is animated, and we copy the fractal onto it by instancing it. And it follows the correct normals of the target mesh. From there, you can then transform it using any standard method within most modeling software, translating, rotating, scaling. However, if there were more than one fractal in this demonstration, you could select a specific one by going to the geometry spreadsheet and finding its ID number, typing it in, and then you'll be able to control it, as you can see. From there, it's unpacked and we put it through the Boolean process. Once it's done, we then notice that it has its intersection. However, because the fractal itself is such a high poly mesh, it keeps its internal structure but doesn't cut the mesh. And so what we have to do is simply select the points which are intersecting, which is done through this, as you can see, and then we delete the points. We then make the normals correct orientation so that we can get a nice visual. Just delete that. And then we fuse any points together to ensuring it's a closed mesh. You can then color it by simply putting through the density, and this can also be used with a material as well. And it is essentially it. Because it's just geometry, it can be rendered through Mantra relatively quickly, and any shaders that you have on a mesh beforehand, as you can see, get kept in the same process. That is essentially my whole tool, and I must warn you, if you're using more than one fractal, it will increase the computational time of generating the fractal exponentially. So there is that to worry about. Thank you.